When you think about the biggest dangers in space, your mind probably jumps to massive rocket engines or maybe cosmic radiation. But what if I told you that one of the single biggest threats to our missions on the moon and Mars is actually microscopic? Okay, let's dive into this incredible story about how NASA is using a surprisingly simple force to solve a very gritty problem.
So what is it? What's this tiny threat that can put billion-dollar hardware and even human lives at huge risk so far from home?
The answer is dust. But hang on, this isn't the kind of dust bunny you find under your couch. We are talking about lunar dust.
And let me tell you, this stuff is nasty. See, on the moon, there's no wind or water to smooth particles down over millions of years. So they stay incredibly sharp, kind of like microscopic shards of glass. These abrasive little grains can literally wear away at spacesuits, jam up complex machinery, and completely wreck sensitive equipment. It's a huge, huge engineering challenge.
So, how do you deal with an enemy that's absolutely everywhere and gets into everything? Well, a team at NASA is turning to a fundamental force of nature for a really elegant solution. All right, the official name is a bit of a mouthful, the dust-tolerant magnetic coupler for cryogenic fluids. But its whole purpose is to help astronauts safely and easily transfer those super-cooled fuels that are absolutely essential for any long-term mission on the moon or Mars. And here's why this is such a game changer. On the left, you've got the old school approach, these complex mechanical couplers with all sorts of nooks and crannies where that abrasive dust can get trapped and just cause chaos. But now look at the right. That's the magnetic solution. It's smooth, it's simple, and it's sealed by magnets. There's literally nowhere for the dust to hide. This new approach delivers three major advantages, what we're calling the three big wins. And each one directly solves a core problem that astronauts are going to face out there. First off, it takes way less force. An astronaut in a bulky, stiff spacesuit doesn't have to wrestle with a connector. The magnets just do the work. Click. Second, as we just saw, it's incredibly dust-tolerant. That simple, smooth surface is the key. And third, it's self-aligning. The magnetic fields just naturally pull the two halves together into perfect alignment, which makes getting a secure connection so much easier. Now, a brilliant idea like this doesn't just appear out of thin air. It comes from brilliant people. So let's meet the team that's making it all happen. The project is being led by Principal Investigator Shide Nattari. Her story is pretty amazing. She started her journey at NASA as an intern, and now she's leading this really cutting-edge research at NASA's Armstrong Flight Research Center. And her experience just speaks volumes about how much NASA commits to new talent. This quote, it really gets to the heart of it. This project isn't just about developing technology. It's about developing the next generation of leaders. The opportunity she's talking about, it comes from a really special program called the ECI. The ECI, or Early Career Initiative, is a NASA program that's specifically designed to find and fund promising ideas from its up-and-coming researchers. It gives them the chance to lead, to manage, and to develop these transformative concepts for future missions. And we are not talking about some small side project. Naddari's team received a $2.5 million award over 2 years to bring this magnetic coupler to life. That's a serious investment, and it shows you just how much potential NASA sees in this tech. So with that kind of backing, where is the project right now? Let's take a look at its journey, from the drawing board all the way to an eventual touchdown on another world. And believe me, this is way more than just a concept. The project has already blown past major milestones. The magnets have been tested in extreme temperatures that simulate spaceflight conditions. Force testing is happening right now, and the actual hardware is being built as we speak. This is happening. And it is a true team effort. This project involves collaboration between multiple NASA centers, from Armstrong out in California to Kennedy over in Florida. It also includes a commercial partner, which shows how NASA works with private industry to really push the boundaries of what's possible. Ultimately, it all comes back to this one thing: enabling our future in space. This technology isn't just some clever gadget. It's a vital tool. A tool that will make it easier and safer for astronauts to live and work on the moon and eventually on Mars as a part of the Artemis missions. And this whole story just leaves you with a fascinating thought, doesn't it? Magnets, they're a force we experience every single day, and yet here they are, solving an incredibly complex, futuristic problem. It kind of makes you wonder, What other simple, everyday forces are just waiting for a brilliant mind to apply them to the next great challenge of space exploration?